Hi, in this video we are going to take a look at how we can get our Docker environment set up, so that we can work with images and containers. Let's get started. These are the steps that we need to follow to install Docker in our machine. First, we need to sign up in docker.com. We will get a Docker Hub account. After that, we can download and install Docker Desktop in our machines. Once installed, we need to log into Docker with the Docker ID that we created earlier and then verify Docker installation with the Docker version command in the terminal. If installations are correct, then it will show the details of Docker client and Docker server. Please note that in older versions of Windows like Windows 7 or 8 we need to install Docker Toolbox. In Windows 10 or higher you can still use Docker Toolbox, but Docker Desktop will provide much better and unified experience across different operating systems. In Linux operating system, the installation process is different. A link with details are included in the description. When we installed Docker, it was not just a single software, but what got installed was an ecosystem of tools like Docker Client, Docker Server, maybe Docker Compose, etc., which together with container registries like Docker Hub can help us build and manage images, as well as run and manage containers. If that was a lot of new terms, don't worry, we will start slow with images and containers. Image is a single file with all dependencies and configurations required to run a program, and the container is an instance of an image. A distant analogy would be to equate images to static code and files, and containers to running programs while executing those files. An image, if we look a little closer at it, is just a group of directories and files. Along with the files and directories, there is this option of attaching a startup command, which in most cases is used to kickstart a process from those files and directories. We will get to know this when we create our own images later. Here is what happens behind the scenes when we take an image and turn it into a container. First, the kernel in the OS is going to isolate a little section of the hard disk and make it available to our container. Then the files and directories from the image is taken and placed into that section of the hard disk. After that, the startup command is executed, which starts the process that is isolated into the set of resource available to the container. Thus, a container is a running process along with a subset of physical resources that are allocated to that process specifically. Now we will see it in action. Docker run hello world is the command, where hello world is the name of the image. It first says unable to find image locally. Then something happens in the background and it pulls the image from somewhere. Once the image is pulled in, lot of text is printed in the terminal. We will have a closer look at it. In fact, what is printed on the screen are the steps that happens under the hood when we execute Docker run command. On receiving the command, Docker client directed it to Docker server. Server checked in something called image cache in our machine. Since we are running this for the first time, hello world image was not available in our image cache. So it looked up in a free container registry named Docker Hub, and found this hello world image. Docker server downloaded this image file, which is a single file with all dependencies and configurations to run a program, and stored it in the image cache. And then Docker server creates a container from the image which runs the executables and produced the output that we saw on the screen. One thing to note here is, if we execute the same command again, we will not see the unable to find image locally message, as the image is already available in the image cache. Another point is, hello world is one of the most simplest of images. The container exited after printing the message in the terminal, but other containers can keep on running as long as we want them to. Moving on, we will now see more production-grade images. First, we will see how we could create a container running nginx server. Nginx, as you know, is an open-source lightweight web server that excels in serving static content quickly. The command is docker run-p 80:80 and the name of the image, which is nginx. If you are doing this for the first time, the image won't be available in the local cache, but it will be pulled from Docker Hub, and then the startup command kickstarts the server. Once started, it can be verified by checking localhost in the browser. We had some extra parameters in the command for running nginx in the form of -p and port numbers. That is meant for port forwarding. When we enter localhost :3000 in the browser, the request comes to our local machine on port 3000. The traffic coming to our computer is not routed to the container by default. Since our application is running inside the container, we should explicitly set up a port mapping for the traffic to reach the container. In fact, the port mapping means that, when somebody requests a particular port in our machine, it should be routed to a port in the container. As we discussed earlier, container will have the files and directories which was part of the image, from which the container was created. We can get a command prompt inside the container and get into that file system. For that we need few new commands. Docker ps is the first command. It returns the details all currently running containers. In our case, nginx is the only container running. We will take the container ID and use the docker exec command to get a command prompt on the container. Once we are into the shell, we can execute our basic Linux commands. ls will list the files and folders. We can create new files. See this text file created. Other basic commands like echo and export will also work as expected. Once done, we can exit the shell using exit command. The exec command helps us run another command against our container. The -it flag in the command helps us to provide input to the containers and also help format the output in a nicely presentable way. In this video, we discussed Docker environment setup, images and containers. We also experimented with creating a container and getting a command prompt in it. In the next video, we will discuss how to create our own Docker images. Thanks for watching.